The Leslie's cube will show us how some surfaces are better emitter of infrared radiation than others. To detect the amount of radiation they emit, we need an infrared thermometer probe connected to a voltmeter. The more infrared radiation an object emits, the higher the reading would show on the voltmeter. This Leslie's cube has 4 different surfaces: shiny silver, bronze, matte silver, and matte black. The lid will prevent energy loss from convection after I pour hot water into the Leslie's cube. I'm going to use some masking tape to mark where the front face of the Leslie's cube needs to be at all time. And I don't want to be varying the distance between the infrared probe and the cube. To keep the probe pointing towards the middle of the Leslie's cube at a fixed distance, let's tape it down on a platform. Once the apparatus is ready, we're going to bring some water to a boil. Fill the Leslie's cube with boiling water, which has a temperature of 100 degrees Celsius. So we can expect the interior of the Leslie's cube is now also at 100 degrees Celsius. Be sure to put on some heat-proof gloves when handling the cube. When I turn the voltmeter back on with the probe pointing at the black surface, the needle of the voltmeter goes off the scale. This tells us that the matte black surface is emitting large amounts of infrared radiation. But when I point the probe at the matte silver surface, the thermal radiation drops significantly. We can see that even though the interior of the cube is uniformly at 100 degrees Celsius, each surface emits a different amount of radiation. The bronze emits more radiation compared to matte silver, but not as much as matte black. And a reading for shiny silver, it's close to 0. So in the order of best to worst emitter of infrared radiation, we have matte black, bronze, matte silver, and lastly, shiny silver. Shiny silver is the worst emitter because it reflects most of the thermal radiation back into the hot water, whereas matte black is able to absorb most of the thermal radiation from the hot water and then re-radiates this energy, making it a good emitter. So this implies that if matte black is a good emitter, by default, it's also a good absorber of infrared radiation. Thanks for watching my video. Be sure to subscribe for more physics.